Hello class, this is recording for section 4.1, example 6. In class, we wrote out the 8 steps that we will be using. Now, if you were absent or if you didn't hear me the first time, in the book, okay, in your textbook, it will ask you to use 8 steps to analyze. I don't want you to use the 8 steps from the book. Again, I do not want you to use the step from the book because there is a couple of things that I change, okay? So make sure you use the 8 steps from your notes, okay? So let's work these out. Here we go. Analyze each polynomial function by following steps 1 to 8. Step 1, according to what we have written up there. You are asked to decide the end behavior of the graph. So the end behavior is when you FOIL them all out, right? But do you really have to sit here and multiply these all out? No, you don't, okay? You can check it out. When I take the leading coefficient of each factor and I multiply, I would have x times x is x squared, times x again is x to the third. So my end behavior or power function, okay, it's f of x equals x to the third. So what does that really mean? It means that when I graph this out, which I will need to, so let me find where I am going to graph. I will need to, there you go, graph this out. So let's go and find this, okay? Here's decimals. So you have a graphing calculator, but I'm using decimals, but they should be giving me the same thing. Okay, so the decimals equation says that I need to plug this in. Well, let's just follow the steps and then we'll get back to that. Okay, so let's go back to this one. Okay, so step 1, end behavior, aka power function. Got it. Step 2, find x and y-intercept. X-intercept is when y equals to 0. So 0 equals x minus 1 times x plus 4 times x minus 3. Okay, these are already factors, so I'm just like each factor, set it equals to 0. X-intercept is exactly the same as finding the real zeros. Okay, so when I subtract and add, so here we go. If I add 1 to both sides, my first x-intercept, it's x equals 1. When I subtract 4 from both sides, my second x-intercept is x at negative 4. And then my third x-intercept is x equals to 3. So you can leave them just the way they are, or you can write them as an ordered pair. Let me find the y-intercept, and then we can maybe put them together. Because it just said find x and y-intercepts, okay? Y-intercept is when x is all 0. So y equals 0 minus 1 times 0 plus 4 times 0 minus 3. Well, 0 minus anything or add anything, it's itself, right? So these are what we have left, which is going to give me a positive 12. So x and y-intercepts, I will put them in order pairs because I think that will look a lot prettier. So x-intercepts are 1, 0, negative 4, 0, 3, 0, and 12, 0. Oops, I'm sorry, that was y-intercept. Y-intercept is when x is 0. So x is 0, 12 is what we have. So if you have work all there, then box it up. Okay. Step 3, determine the zeros and the multiplicity. I can't speak. Determine the zeros and their multiplicity. Use this information to determine whether the graph crosses or touches the x-axis. Well, we are in luck because step 3 is asking us to find the zeros. Finding the zero, it is looking for, or the real zeros, and that is looking for the x-intercept. So I don't have to do any more work. I just have to write them down. Woohoo! Okay, so step 3, okay, we are now going to write down the zeros and their multiplicity. Zeros are x equals negative 4, multiplicity of 1. X equals to 3, multiplicity of 1. They all have a multiplicity of 1. Okay, x equals to, what am I missing? 1. Multiplicity of 1. I have too many L's in there. Oh, there you go. They all have a multiplicity of 1 because each one has an exponent of 1 if they don't have any exponent written on them. Now it says, hey, is the graph going to cross or touch? Because 1 is an odd number, so the graph will cross, okay, at each x-intercept. Graph will cross at each x-intercept. Okay, or you can call it at each 0. Okay, so that's step 3. Step 4 says create a number line to find points on the graph around each x-intercept. What does that really mean? It means this. Step 4. Number line is just a number line, okay? And it says it's using x-intercept. So see this right here? So I'm going to plug in x-intercept. I found 3 of them. X-intercepts right here. Okay? So I will plug in order, -4. It doesn't have to be just scale, okay? And what does it mean when it says find the, create a number line to find points on the graph around each x-intercept? That means I'm just going to pick, okay, something over here, something on the left of -4. So on the left of -4, I will pick -100. Why do I pick -100? The reason is that I'm going to plug it back into my equation, okay, and see if it's positive or negative. That's all I'm really looking. So when x is -100, plug it in. -100 minus 1 times -100 plus 4 times -100 minus 3. Am I really going to sit here and multiply these out? No, I'm not, okay? -100 minus 1 is a negative answer. I don't really care what the answer is. I'm just trying to see if it's going to be, if the y value is going to be positive or negative. -100 plus 4 is negative, okay? -100 minus 3 is also negative. Okay, a negative times a negative is a positive, but a positive times a negative is now a negative. So over here, you're going to have a negative y value. Why do I need to know that? Because when I graph it by hand, okay, it's going to help me to start. Do I start at the bottom or do I start at the top? That's really the whole point, okay? Then in between -4 and 1, I'm going to pick a nice number, like 0, okay? 0 minus 1. Again, I'm not interested in what the actual number is. I'm interested in positive, negative. So plug it in. Let me get a highlighter. 0 minus 1 in that piece. Is that positive or negative? It's negative, right? Then the next piece. 0 plus 4. Positive or negative? Positive. Okay. Next piece. 0 minus 3. Positive or negative? Negative. So a negative times a positive is a negative. A negative times a negative is now a positive. So in between here, y would have to be above the x-axis. That's the whole point about step 4. Determining when is y above and when is y below the x-axis. Step 5. I'm sorry, I still need 2 more intervals to go. Whew, I got too excited. Okay, so I'm between 1 and 3. I will now pick 2. Okay, so 2 minus 1 is 1, so that's positive. 2 plus 4 is 6, so that's positive. 2 minus 3 is negative, so this is going to give me negative. Okay, then next one, I'm going to pick some ginormous numbers. Okay, for the whole point, it's easy for me to do the calculation. 100 minus 1 is positive. 100 plus 4 is positive. 100 minus 3 is positive. Positive times a positive times a positive is positive. So it looks like the end behavior is starts on the bottom and it goes continue to finish up on the top. So that's what step 4 is doing. Step 5. Step 5. Approximate the turning points using the calculator. So this is when I really have to graph it out and find the max and min. Okay, so let's go find the max and min. Okay, so your equation was open quantity, x, what was that again? X. Sorry, it's really difficult for me to do this without seeing it all. Where is that? X minus 1 times x plus 4 times x minus 3. Okay. X minus 1 times x plus 4 times x minus 3. Okay, so here's my graph. Okay, let me zoom out. Make sure you zoom in. There you go. So turning points is when you're looking for the maximum and minimum. So on your own calculator, you can totally find those by using second trace max, okay? And then on the minimum one, you use second trace min, okay? So they are at negative 2.082. So it looks like decimals rounded to 3 decimal places. You can totally round to 2. I don't mind that at all. So negative 0. Let's do 2 to keep it consistent. Negative 2.08, comma 30.04. Let's go back. Okay. Step 5, approximate the turning point of using calculators. So negative 2.08, comma 30.04. And the other one was, what was the other one? And positive 2.08, comma negative 6.04. Okay, so almost like symmetrical over, almost. Okay, don't say that it's symmetrical, almost symmetrical. So positive 2.08, comma negative 6.04. Positive 2, oh, what was that? Positive 2.08, comma negative 6.04. So those are the two turning points that we got by graphing out, okay? Use steps 1 to 5 and graph the function by hand. So let's do that. That's your step number 6. Step 6, okay? So I'm gonna try to squeeze this in here. I'm trying to run out of space. I'm hoping you have more space than I do. The y value is, the max is at 30, so I'll probably scale this by 10, 20, 30, okay? 10, 20. And the x is not very big, so I'll still keep it at 1. So 10, 20. X is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I don't have to label my x because it's just by ones, okay? So step 1. F of x is equal to x to the third. I don't need to really do anything about that. Step 2. The x-intercept is at 1. So the first one's at 1. The next one is at negative 4. 1, 2, 3, 4. The next one's positive 3. So those are the x-intercept. Step 3, 0 multiplicity is all going to cross the x-axis. Okay. The y-intercept's at 12. So that's right there. What else do I need? Step 3, step 4. Okay, so this is where it's going to help. Let me plot step 5, which is the max and min. So the max, it's going to be negative 2.08 and 30 units up. Right there. Okay, so that's your max. Your min is 2.08 and a negative 6. So right there. So we did that. We did not do step 4. So this is how step 4 is going to help you. So notice how step 4 says we are going to start out on the negative side right here. Okay. What does that mean? That means my arrow is on the bottom. I know, right? Amazing. And it said in between negative 4 and 1. Y should be positive. See this right here? That means everything has to be above the x-axis. And is that true? Okay. If I connect my dots and you miss a dot, you make it fat, okay? And that's really true. Look, I just drew everything that's positive. Then it went on and said, hey, in between negative 1 and 3, the y is negative. That means I need to be below the x-axis. And that's also true, okay? Then it says, well, everything on the right-hand side of 3 should be a positive. That means you shoot up and you make an arrow up. Voila! Okay. And look, doesn't that look by hand? Doesn't that look like what I did using decimals? Okay, so totally. Now, let's talk about the power function or the end behavior, okay? The end behavior says that y equals f of x. Now, how does that look like? How is that the same? Well, the end behavior is really talking about, oh, it's not letting me minimize, there you go. The end behavior is really talking about what happens when x gets really big, okay, like that, okay? Now, x is in the thousands. Can you see that the two functions, the red and the blue, are almost identical, okay? And that's what it really means by the end behavior, when x is really big, both positive and negative. But when it's not big, when I really go back into great details, okay? As you can see, when I do this, they're not exactly the same at all, okay? But when x is really big, whether positive or negative, the two of them can almost overlap. That's amazing, right? So that's why it's important to find the end behavior or the power function. All right, let's finish this up. We got step 6 in. Step 7, let's write it right here. Step 7 says, what do? Find the domain and range. So the domain and range are both all reals. All reals, range, all reals. And last one, step 8. Step 8 says, determine when the function is increasing and decreasing. All right, so let's do increasing first, okay? Increasing looks like it starts at negative infinity and it stops right there. So negative infinity, and that x value was the negative 2.08. So negative 2.08. Okay. And another one is from here, right? Increasing there. So at a positive 2.08 all the way to positive infinity. So that's increase. Decrease. So decreasing interval, there's only one of them. So that's going to be from negative 2.08 all the way to positive 2.08. And I believe I have taken care of all 8 steps right there in that beautiful screen. And this is the end of example 6A.